This is a problem from section 3.7, the section that talks about related rates, and this is number 17. At a sand and gravel plant, sand is falling off a conveyor and onto a conical pile at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high? So here, like they say, we have some sand that's falling off of a conveyor and it is forming a pile that's in the shape of a cone. And the formula that we'll be using here is the volume of a cone. Volume is equal 1/3 pi r squared times the height. So what they've given us here is, let's write out what's given. Remember, let me write it down here. What they gave us. dV over dt, the rate of change of the volume, is equal to 10 cubic feet per minute. And they also gave us that the diameter of the cone, of the base of the cone rather, is equal to 3 times the altitude, or 3 times the height. Altitude and height are the same thing. Okay, so 3 times the altitude or 3 times the height. So D is equal to 3h. Now, notice in our formula we don't have D, we don't have the diameter, we have the radius. Well, from here, I know that the radius is half of the diameter, so that means that the radius is going to be half of 3h. So our radius would be 3 over 2 times h. Why is this helpful? Well, this allows me to substitute r into our problem, and then into our formula rather, function that only has h's in it, and it does not have two variables, an r and an h. But before I do that, let me go on and see what it is they want us to find. So we're given that the rate of change of the volume is equal to 10 cubic feet per minute. So dV over dt is 10. And we now know that the radius is equal to 3/2 the height. Now they want us to find the rate of change, or at what rate the height of the pile is changing. That's going to be dH over dt. And they want us to do this when the height is equal to 15. So these are the two things that we have been given, or the few things that we have been given. All right. So now what we're going to do is we're going to use this, plug into our formula. V is equal to 1/3 pi times 3/2 h squared times h. Simplifying this, we get 1/3 pi times 9/4 h squared times h, and multiplying everything together we end up with, well, I can cancel this. 3 goes into that 1 time, that should be a 1, that goes into that 3 times, so I'm left with 3 pi over 4 times h to the 3rd power. So now we're ready to go on and find the related rates formula or equation that we're going to use in order to help us to solve the problem. Now that we have our formula, we can go on and find the derivative. So we want to find dv over dt. dv over dt is going to be 3 pi over 4 times 3h squared times dh over dt. Okay? Okay, so let's simplify the right side. dv over dt is equal to 9 pi h squared over 4 times dh over dt. So let's plug in what's given. dv over dt we know is equal to 10, so 10 is equal to 9 pi over 4, and they gave us h is 15, so this is going to be times 15 squared dh over dt. And remember, we're supposed to find dh over dt. So we're going to solve this. We end up with 10 is equal to 9 pi over 4 times 225 dh over dt. So 10 is equal to 2025 pi over 4 times dh over dt. Multiply both sides by the reciprocal of 2025 pi over 4. We end up with 40 over 2025 pi equals dh over dt. And we're going to divide that, or simplify the left side. 5 goes into 40 8 times. 5 goes into 2025 405 times. So dh over dt is equal to 8 over 405 pi. So to answer the question, what is the at what rate is the height of the pile changing when the pile is 15 feet high? And the answer is 8 over 405 pi feet per minute. I hope this helps. Please let me know if you have any questions. Bye-bye.